Hello and welcome back to Calculus 1, section 3.2, function, the derivative as a function. There we go. We discovered few of those functions in the last section. Why? There we go. We had that f of x was equal to, let's say, 5 over x, and then the derivative f prime of x was negative 5 over x squared. We also had an example where f of x was square root of 2x plus 1, and then f prime of x was 1 over square root of 2x plus 1. We also had an example when f of x was x squared minus 3x minus 1, and f prime of x was 2x minus 3. So these create, as you can see, pairs of functions. You have f of x, which is our original function, and then we have its derivative, which we found through that limit. And we use that derivative to calculate the slope of the tangent line. Now, each one on the left is a function. Each one on the right is also a function. We call it derivative, but that function is used to calculate the slopes of tangent lines. So now, what I'm going to do is I'm going to talk about the relationship between the function and the derivative. So that's what we are focusing on. Relationship between function and derivative. So if f of x is given as x squared, I will tell you that the derivative is 2x. Now, you know the way to find it. You go and you calculate f of x plus h and all of that good stuff, and eventually you come up with 2x. So now what I'm going to do for the rest of this lecture is I'm going to use red color for derivative and its graph, and I'm going to use black for original function and its graph. So now if I am to graph both of these functions on the xy coordinate system, the black function x squared, and then the red function 2x. The first thing that we notice is that here we have a relationship which states that when f of x has max or min, f prime of x is equal to 0. Goes through x-axis. So this is your first relationship that you are going to see. So when the original function, in our case black, x squared, when original function has either minimum or a maximum, the red function has to go through x-axis, has to have a 0 there. Another relationship that we are going to learn from this image is that on any interval from x1 to x2, where the function is decreasing, the derivative is negative. And for any part where the function is increasing, the derivative is positive. So, if f of x is decreasing on some interval a to b, then the derivative f prime of x is less than 0, in parentheses I'll say below x axis. Orange, if f of x is increasing on some interval a to b, then f prime of x is larger than 0, which means above x axis. So from this one image with two functions on it, we learned 3 key points. There's one more left and we're done. Yes? You see that the red cuts through x-axis? What's the y value for the red line? Is 0. It will, the red line will still be cutting to 0 at that point. Because if the black line has min and max, the red line will go to 0. They have different functions.
So let's assume that the min or max will always be at the x-axis.
No, they can be anywhere. Sines and cosines have infinitely many min and max. And
in this equation, so if f of x was x squared minus 2, then the derivative will be different.
yes.
Oh, I see. So
If f of x is x squared minus 2x, then the function is shifted 2 to the right, and it would have it's not shifted to the right. It's shifted. So the red line is not going to go through. So here's the example. So this is going to be a random function, it's f of x, black, right? And now I want to draw the derivative just by looking at this. I don't know I have no equation, no numbers, I have nothing. So how do I draw the derivative, the sketch of the derivative without doing any of this? Well, that's if we're going to do a point by point, but there are infinitely many points, right? So the way we do this is, here is a max, so it has to cut through the x-axis there. Here is a min, it has to cut through x-axis there. Here's another max, it has to cut through x-axis right there. So to sketch a derivative graph, we, number one, find all x locations for min and max. So as you can see, I located all of the min and max points on the graph, and I placed x-intercept points for the red. So my red graph has to go through those 3 red points on the x-axis. Then I use the next piece of information, which is if the graph is increasing, derivative is above x-axis. Well, this part over here is increasing all the way up to the maximum. So the derivative has to be on this side. I don't know if this derivative goes like this, like that, like that, like that. I don't know. I really don't know which one of these lines. But what's important is that the derivative is above x-axis. On a decreasing part, the derivative has to be below x-axis. And I'm happy because, yay. For this increasing part, the derivative has to be above x-axis, and then I have another decrease coming up. So a bump up, and the function going down afterwards. So if I now partition this using this light blue line, in this area over here, we see that the function is increasing, the black one is increasing, and we see that the red line is above x-axis. That's a requirement. If we go the next section has decreasing part, and we see that the red line is below x-axis. The next section, we have the increase again, and we see that the red line, which is the derivative, is above x-axis. And finally, the last fourth piece is decreasing, and the red line is below. So now you can just make this smooth, and the red line is the sketch of f prime of x. Is this exact? Hell no.
I'm wondering why
Because we don't know how tall these bumps need to be, how deep they need to be. They can be any of those. We will be calculating these exactly eventually. Right now, we are only learning the relationship between the graph. What's your question?
I'm wondering why the f(x) is increasing at the beginning to cross over the y-axis, but the derivative is decreasing at the same time. So f(x) does start decreasing.
The rule that we are using is that the derivative is positive. If the function is increasing, the derivative is positive. We do not worry about increase or decrease of the derivative.
Obviously, it has to be positive.
We are, because these functions are not the same. We are using two different concepts that are linked. increase and decrease of the original function with positive and negative of the derivative. We are not mentioning increase and decrease of the derivative at all.
I'm sorry, I'm having trouble keeping track of that.
These are the blue and orange.
Of course, yes. So
Blue and orange.
that's increasing, then the derivative has to be in the positive, yeah, and the negative plane.
Yes, that's it. That's all it is. Yes.
It's just weird in your sketch was a little bit just like shifted it over. Like it looks like if you were to like follow it, you just took the original and then you shifted it, and that's the
That's perfect observation, and it's always true for polynomials, except this polynomial here, which is, right? It will also be true for sine and cosine, and it will not be true for anything else.
okay. Is that just because like you're technically looking at like the tangent line of it, so it's gonna be like when it's increasing the tangent,
Yes.
Right.
Perfect. So number 2,
So you said that
all
that a polynomial
increasing.
that's going to look like a so the polynomial is going to look like a reflection of it, or translation of the world.
It's just shifted, but as I said, don't learn calculus example by example, because that's just, polynomials are just one example. I'm going to now work on a function that is not a polynomial, so we have to be careful then. Next function. So I connected 3 to 6. Then I went flat to 10. Then I dropped 2 units to 12. Went flat to 15. And then drop down into 19 on x-axis. So this is my f of x. We can draw the derivative function exactly for this one. So what should be the line for the derivative between 0 and 3? Positive. And what value should it have? It's a straight line, so 2. Exactly. The slope of the black line from 0 to 3 is 2. So for the derivative between 0 and 3, we will have a flat line because the slope is everywhere 2. we will have the flat piece. What's happening next? No slope, which means derivative is 0. The next piece is constant piece. There is no change. When something is constant, there is no change. So derivative is 0 from 3 to 10. Now, from 10 to 12, it dropped down 2 units. So what should be my derivative?
Increase.
What's the value? -1. The slope from 10 to 12 is -1. And then 12 to 15 is 0 again, because it's constant. And then it drops 4 units in 4 squares, -1 again.
Oh, that's -4 squares.
Yes. So -4, -4 down, and 4 forward. So we learned now that the new concept here, we learned that constant piece has 0 derivative. Because there is no change. So there's no change when the function is constant. All right. One more quick thing, and we are done. Earlier we had, if f of x is 5 over x, f prime of x is -5 over x squared. We know that 1 over x squared is the graph that looks like this. You should have learned this by now because we used it many times.
Yes.
So now, if I draw five over x black, and then I need the red one, which is -5. Over x squared. So x squared positive should be going up. This one is going down because it's negative. So now that's my f prime of x, and the black one is f of x. The big reveal here is that the vertical asymptote stays at the same spot. That's the big one. So, vertical asymptote stays in the same spot from f of x to f prime of x. There is a vertical asymptote here, which is the y-axis is a vertical asymptote, and we see that it's the same vertical asymptote for both functions. And now observe that the 1 over x or 5 over x is always decreasing. Therefore, the derivative is always negative. We see that the first part of the black function, right, goes down towards negative infinity, right?
Yes.
So the red function better be below x-axis, and it is. This part is also decreasing. Starts at positive infinity and drops down to 0. So always decreasing. This one is also below x-axis, which obviously confirms what we had before. So this entire section is this graphical connection, and you guys learning that min and max will give 0 on the derivative, constant piece will give 0 on the derivative, vertical asymptote is preserved, and then increase and decrease going above and below x-axis.
The asymptote will be the same. This applies for all functions and relations between functions and derivatives.
Yes.
All right.
And that is it for today. Tomorrow we'll do 3.3 and the review. Make sure you bring problems to the class so we can do the review.